triangle, you could find the third side. Didn't allow us to do anything with the angles. Then we looked at two special right triangles, the 45, 45, 90 and the 30, 60, 90, which again are fairly rare, but did allow us to find that information given only one side and the knowledge of what kind of triangle it is. We could find all the other sides. Today we're going to get into trig. And trig allows us to solve any right triangle if we have at least two pieces of information. And sometimes those pieces of information will be two sides, sometimes it'll be a side and an angle. Of course, that's based on the idea that it is in fact a right triangle. So this opens up a whole new world for us to solve triangles. Okay, so in general, when we label a triangle, let's say we name the triangle ABC, where C is the right angle. We're going to start introducing this idea of lowercase letters being opposite the angles. Okay, so if this is angle A, then lowercase a would be the length of the side opposite A. Vertex B would be have lowercase b opposite it, the side opposite that. And then if C is the hypotenuse, then if C is the right angle, then lowercase c would be the hypotenuse. If the letters change, that's okay, as long as that naming system still works out. So if you have a triangle PQR, then lowercase p is going to be opposite angle P, lowercase q is going to be opposite angle Q, and lowercase r is going to be opposite angle R.
Just to refresh, what was the like symbol for like a midpoint, like the little?
There is no symbol for midpoint that I know. Because what's going to happen is you're going to be given a problem that says something like, in triangle PQR, angle P is 42 degrees, side P is 12 meters, and side Q is blah, blah, blah. So you're going to have to be able to draw the triangle. You won't always be given the triangle. Okay, does this make sense? Okay, good. The other thing we're going to talk about is if I take angle A, for instance, there are three sides in relationship to angle A. There's the hypotenuse, which is which side? C. There's the side opposite angle A, which is A, right? That's why we call it A, because it's opposite angle A. And then we have the adjacent side. What does adjacent mean?
B, next to.
Next to. In this case, it would be B. If you change the angle, if we come over to B, which one's the hypotenuse? Still C, that didn't change. Which side's opposite? B, and which one's adjacent? So you might be saying to yourself, wait a second, C and A are both adjacent to angle B, but C has to be the hypotenuse. Okay? If you can identify those three sides, then trig is going to be easy for you. Because trig is defined in the following way. Well, first of all, there are actually 6 trig functions, and they are functions. Okay, by functions I mean you put a number into the function, it does some math magic, and it spits out another number. We're only going to look at 3 of them: sine, cosine, and tangent. And they're abbreviated sin, cos, and tan. Don't call them sin, cos, and tan. People will laugh at you. Sine, cosine, tangent. And if you bust out your calculators, in other words, bust out your calculators, you will find 3 buttons on your calculator that have sine, cosine, and tangent on them. Okay, back in the old days, I don't know if anybody actually ever looked at this hall pass, but this hall pass used to be a desktop. And so Rex will attest to what's going on there. See all those numbers?
Yeah.
So what your calculator does, we used to have to use either charts for, or this was actually a desktop. So if you were doing graphing, you would flip it over and use the graphing side. If you're doing trig, you'd flip it over, and then all the trig charts are on here. Okay, we'll come back to this in a second. Leave it right there. Okay, so we've got these 3 functions. What do they do? It's actually a pretty simple concept. The functions are simply ratios. That's it. Okay? It sets up a ratio, and you can see it listed here. So the sine of an angle is the length of the opposite side over the length of the hypotenuse. Even though I have this example here and this ratio, I wouldn't concern myself with this, because what if the triangle is P, Q, and R? This is what's important. The sine of an angle is defined as the side opposite it over the hypotenuse. Cosine is defined as the adjacent side over the hypotenuse. And tangent is the opposite over the adjacent. So sometimes when you talk to people about right triangle trig, they will use the following phrase. So katoa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so we're going to start simple. Have you got this, by the way?
No.
And again, these ratios on the end aren't very helpful except for this one particular triangle. We're going to be naming our triangle all kinds of different things. So it's more important that you remember opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, here we go. Here's a right triangle. How do I know it's a right triangle? Well, a couple reasons. I put the little red box in the corner. I also know that 3 squared plus 4 squared is equal to 5 squared, so it satisfies the conditions for a right triangle. And we want to know what's the sine of A, the cosine of A, the tangent of A, the sine of P, the cosine of P, and the tangent of P. These are simply ratios. It's not going to tell us how big the angle is yet. We're not ready for that yet. We're just going to set up a ratio. All right, so let's try this. What's the sine of angle A? Say again?
4/5.
Is he right?
Yes.
Here's angle A. Sine is defined as opposite over hypotenuse. The opposite side is 4. The hypotenuse is 5. Beautiful. What's a cosine of A?
3/5.
David? 3/5. How about the tangent of A?
4.
Max?
4/3.
4/3. Okay, let's stop for a second. Does everybody see where we're getting those numbers? If I look at angle A only, the side opposite it would be the 4, the side adjacent is the 3, and the hypotenuse is always the 5. Okay? Different angle. By the way, what's the relationship between angles A and P? Camille, did you get a new sweatshirt?
No.
It's really nice.
Yeah.
It's really nice. Yeah, that's good. Did you get a haircut over the weekend? Your hair is looking great. No? Camille, you've been working out? You're looking pretty buff. Nobody's picking up on this, huh? What's the relationship between angles A and P?
They're the same.
I'm sorry?
Complementary.
They're complementary.
Oh.
See what I was doing there? Yeah.
Oh.
Shut up. Don't need your condescending laugh. The one symbol, ha. What's the sign of P? David?
3/5.
3/5. Keep going, David. What's the cosine of P? And the tangent of P?
Uh, 5/4. No.
Nope.
Wait, shit. 3/4.
Good. Notice the relationship here. The cosine of angle P is the same as the sine of angle A. The cosine of angle A is the same as the sine of P. And what's the relationship between these two guys? They're reciprocals, correct. Flip them over. All right, let me clear this mess out. What happens when we try to take the tangent question?
Yeah, what was the, for the numbers you wrote in blue, was that the sin cosine of A or E?
A.
Alright, thanks.
What's the tangent of E? I'm sorry?
5/3.
5/3. Why? Opposite over adjacent, right? Yeah, 5/3.
Yeah.
Why not 5/4?
It looks better.
It looks better. Okay, good. Uh-huh.
Approach.
Yeah. What about the sine of E? Which is 1. What about the cosine of E? What's the problem with the cosine of E? There's 2, so we run into the same problem. The way we handle that is we try to avoid working with the 90-degree angle. So we're going to try, and we'll talk a little bit about this when we get on the calculators, but so sine, cosine, and tangent of the 90-degree angle, sometimes things get a little wonky. And we've seen already which one's adjacent. Once we go to this being the hypotenuse, which of those two angles is adjacent. Okay. So, on your calculators, before we get started, find the mode button. It's in the top left-hand side. Hit the mode button, and make sure you have degrees highlighted, not radians. Highlight it and hit enter if it's not.
I'm confused.
How are you confused?
Mode button,
Press it.
okay? I think it's the second or third thing down. It says radians/degrees.
Yeah.
Make sure you have degrees highlighted
You press enter.
and hit enter.
Oh, got it.
Okay. Now that's really important because if you're in the wrong mode, you will get answers out of your calculator. They'll just be wrong. Okay. So if you're looking to play a good practical joke on your neighbor, right before the next test or quiz, just reach over and put their calculator in the other mode. That's always a good time. You can change the language too if you'd like, but that would be too obvious. So to make sure we're all on the same page, find the cosine button and hit the cosine of 41 degrees.
Where's the degree sign?
You don't need the degree sign, you just do cosine of 41.
It's that's the one.
We're still dead. I only have 3 AAA batteries at home.
Smart though. See, nicht sehr gut, meine Schatzi.
What did you get, Jimmy?
Everybody get 0.7547?
Yeah.
Beautiful. So, Rex, you got better eyes than I do. Find the trig tables on there. I think it's in this center part. So, no, those are logs. Here, comment. No, those are logs. Natural function. Here we go. So there should be a cosine or sine or something. Okay, so what we're trying to do is decipher the trig table now, and Rex is trying to find the cosine of 41 on this desktop. It's not going so well.
It's a lot of numbers.
Lot of numbers, right? And no luck? No, okay.
Just look for 41.
So in textbooks, they used to have a like 3 or 4 or 5 or 10 pages of all the different trig values. And what it wouldn't allow you to do is find things like, what if I want to find the cosine of 41.25 degrees? You couldn't do that. These are right, they're only whole numbers running down here, right?
Yeah.
Yeah, over on this side, the shaded stuff, or the bolded stuff.
Yeah.
Yeah, so it doesn't work so well. But the calculator allows you to do all kinds of interesting things. Just to prove a point, go back to the mode button and put your calculator in radians. And do this first calculation again. What's that, Nick? Negative 0.987. Yes? Okay, so it's still going to spit out an answer, and there's no indication that that's the wrong answer. So again, put it back in degrees. Don't loan your calculator to anybody. Don't let your older brother or sister use it for calc where we're in radians mode. Leave it in degrees mode. It might also be something that you want to get in the habit of checking before every test and quiz or before you're working on homework. Check to make sure you're in degrees mode. Okay? Take the tangent of 74. Make sure you get that. And take the sine of 2 degrees. Make sure you get that. So you might be asking yourself, where are these numbers coming from? Other than the calculator spitting them out. How does the calculator know to do it? Well, the calculator creates an imaginary triangle with a right triangle with a 41 degree angle, and it knows the measurements of the opposite side. This isn't really how it works, but just pretend. And then it does a ratio. This is just a ratio. This is some fraction. You could probably convert it back into a rational form if you had to. Maybe not. But there is some triangle out there that has a cosine or an angle of 41 degrees. It's a right triangle, and we know the opposite, adjacent, and hypotenuse side. Then you just set up the ratio of that thing. When you're finding trig values on your calculator, you're going to round to 4 decimal places. And only when you're finding trig values. If you're finding angle measures and side lengths, we're going to leave that at 2 decimal places. Okay, does that make sense?
Yeah.
All right, good. Any problems with this? All right, so that lays the groundwork for what we're going to do with this. So notice how different this is than what we've done already. It's not a 45, 45, 90 triangle. It's not a 30, 60, 90 triangle, so it's not one of the special right triangles. I don't have enough information to find, to use Pythagorean theorem because I'm missing one chunk of information. So now I have to rely on trig. The nice thing about trig is that you always follow the same procedure. You set up a ratio, solve the problem. Set up the ratio, solve the problem. So we'll do x first. If I'm looking for that, and I know that, and I'm using that angle, do I have to use the 40 degree angle? No. How big is this angle?
50.
50. So you could use 50 if you want. Remember, these are always going to be complementary, but we'll stay with the given information of 40 degrees. If we go from this 40 degree angle, is the x the opposite, adjacent, or hypotenuse? Opposite. Is the given information on the hypotenuse or the adjacent? Hypotenuse. What function uses opposite and hypotenuse? Sine. Sine. So then we set up an equation. The sine of 40 degrees is equal to the opposite side, x, over the hypotenuse, which is 3. How do I solve that? There. Multiply each side by 3. Notice I moved the number out in front because I don't want it to be mistaken or get wrapped up into the sine function. Okay. Do this on your calculator. And do it like that, 3 times the sine of 40. If you're feeling saucy, you can close those parentheses. Say again? 2.29.
1.9.
Are you in the right mode?
I got 1.9.
1.93?
1.928.
Yeah, round up the.
1.93 meters. Doing the wrong mode.
So we are.
So you're in degrees. that answer make sense? Yeah.
So are we rounding for the side?
Sides and angles we round to 2 decimal places.
Okay.
If I just ask you for the sine of 40 degrees, that's a trig value, and now you would take the 4 decimal places. Again, does that answer make sense? What answers wouldn't make sense?
4.
Why?
Because the hypotenuse is the longest side.
Good. One possibility is 4. 4 doesn't work because that length x has to be shorter than the hypotenuse. What else won't work? Dana?
Negative numbers?
Negative numbers. And some of you will manage to find a negative distance. That happens. Okay, but again, if you do a little evaluation there. Okay, so how do I find x now? There's a couple different ways to, or sorry, that's a y. I have trouble with my letters. How do I find y? Oh, by the way, before you do anything else, get in the habit now that you have that answer 1.928 blah 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 on your calculator screen, store that into x in case you need it later. Because this is an approximation and we don't want approximations for calculations, we want exact values. Okay, so now you got to store it in x. Okay, how do I find y? Max?
Well, since we know that angle's 50 degrees, we can do, and we can use sine with y and the hypotenuse and do, sine of 50 is equal to y over 3.
Good. One possibility. How else can we find y? If your full answer's still open.
X squared plus y squared
Woo.
equals 3 squared.
Also known as?
Pythagorean theorem.
Good. We can go back to Pythagorean theorem, which is why I had you store that, because now we're going to do a calculation with that value. Third way. Any other ideas? Max?
You could do with 40, you could do cosine with y over 3.
Cosine of 40 is equal to
Y over 3.
y over 3. Beautiful. Any one of those. As far as preferences from me, I would avoid this. It's not wrong, but this is doing a calculation with calculated information. So we calculated x. Ideally, you're better off staying with non-calculated information. This isn't calculated, it's information. That's not calculated. That, well, technically that is, but we know it's exactly 50 degrees. This is my personal preference, but you could use any one of those 3. You'll all get the same answer. Okay, so solve this. Tell me what y is. Real quick before you finish it, stop what you're doing. Will y be bigger or smaller than 1.93?
Bigger.
Why? Because you've already done the calculation, you know the answer? Yeah, so you cheated. Before you hit enter, how would you know that y would be bigger than 1.93?
The angle opposite of y is bigger than the angle opposite of x.
Yep. Okay, this has got to be smaller than this because this is bigger than that. Okay, what do you got?
2 point. It would be. I think it would be 2.3 if you're under 2 decimals.
Can somebody confirm? 2.3? Okay, so let me illustrate now why we have to be careful with the calculated numbers. If this is correct, then 1.93 squared plus 2.3 squared should equal 3 squared. Okay. Don't use the stored information, just do this calculation. Take 1.93 square it, add 2.3 squared, and see, do you get 9? Yes or no? You did?
Pretty close decimal.
pretty close, but not exact, right?
Yeah,
What is it like? Is it 8.9 something?
it's 9.01.
So it went over a little bit, right? It's still going to give it 9.01, blah, blah, blah. So not equal. And that's why we want to stay away from approximation stuff. And this gets worse the more calculations we do. And we're going to do some fairly complicated calculations in the future. And so we want to try to use given information and or stored information to do the calculations. Okay, so right now you're going to be struggling a little bit because you don't know what these functions are. And you'll get better as you practice. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. But the process is the same. Set up an equation, solve the equation. First of all, is it a right triangle?
Yes.
Beautiful. Because it doesn't work if it's not a right triangle until later. What information do we know? Is that 35? Well, we're going to use the 15.5. Is that 35 the opposite, the adjacent, or the hypotenuse? Adjacent, not the hypotenuse. Notice it's sitting on its hypotenuse. Solve for R, solve for S. Check with your neighbor. Some of you might get a little hung up on solving the equation. If you get the equation set up, I'd be happy. We'll talk about how to solve it in a minute. Real quick, let me interrupt your calculations again. Let's talk about the values of R and S. Will R be bigger or smaller than 35? Smaller. Will S be bigger or smaller than 35?
Bigger.
Bigger, good. So you can use that as the checks and balances when you get answers. If you get an answer for R like 47.8, you probably did something wrong. Set up the wrong equation, et cetera, et cetera. Which one do you want to do first, R or S? R, okay. What equation do I set up to solve for R? From the 15.5 degree angle, is R opposite, adjacent, or hypotenuse? Opposite. And we know the 35 is the adjacent or the hypotenuse? Adjacent. What function uses opposite and adjacent? Tangent. R over 35 or 35 over R? Good, R over 35. And so R turns out to be? Anybody else? 9.71? Good. 9.71 feet. Which again, store on your calculator, just in case you need it. And then find S. What function do you want to use to solve for S? What function don't we use to solve for S? No, we heard enough out of you. I'm sorry? Cosine. Okay, which would give us what? Cosine of 15.5 is equal to? S over 35 or 35 over S, Sterling?
Um,
35 over S or S over 35?
35 over S.
Good. How do I solve that? Come on, algebra 1, how do I solve for S? Multiply by S. So this becomes S times the cosine of 15.5 equals 35. Then what? That's okay?
Put it,
No.
You look on cosine, so 15.5.
Now you put that in your calculator. Notice what happened here. This switches places with that, called the switcheroo. You can go through all these other steps or just recognize that that's going to switch places. What's S?
32.
Say again?
36.32.
Yes?
Yeah.
Beautiful. Does that make sense? Yeah, because we said it's got to be bigger than 35, because it's the hypotenuse. Questions? And again, as you continue to practice this, it's going to become easier because you'll get more adept at remembering and recognizing the sides in relationship to the angles. We could have done that whole problem over again and used this angle measure if we wanted to. But again, why would you bother to do that when you already know that that's 15.5? Pregunta, señor.
Is that a 36.62?
Yeah, I think so. 36.62, is that what you said?
36.32.
3.2, sorry. My bad. Okay. I think we're done for today. Yeah. Okay. Now, we haven't covered one part of trigonometry which we'll save for tomorrow, and that is every one of our calculations we did today, you were given the angle measures. Tomorrow, we want to be able to go backwards and find the angle measures. Okay? So that'll be exciting. You'll have a triangle that's got two sides, it's a right triangle. You'll be able to work backwards to calculate angle measures.
Put in this image.
What's that?
Put in this image.